So this part of the video is going to go through the corrections of the applications, and basically you have to decide in your applications, you know you're going to integrate. You have to decide, am I doing a definite integral or am I doing an indefinite integral and plugging a number in. So number 11 is an indefinite integral because we're finding a particular solution to a differential equation. And you can tell that because there's no bounds, there's no starting and ending point. And so you integrate once and you get an indefinite integral, and then you go to your information and you plug in that point and find c, and c happens to be 0. So we integrate again and we get this value right here with the c, and then we plug in the second point, -8, 1, and you find c. Your final answer, when you find c, goes in for your, and your final answer is an equation. It's not c. The second one also is a differential equation. Acceleration, when they give you acceleration, you'd integrate twice. Integrate once gives you velocity, that would be plus c, and then you integrate again and you get the initial displacement position function, and you find c again. So you don't need an interval, you need an actual number to find c. So it's 11 and 12 are the same question. 12 could have said acceleration is 2x minus 3, and you work from there. So they're basically the same type of question. Number 3, write an integral for the area under the curve. You may use technology. Write an integral means they give you the function. The definition of area is a definite integral of the function from the starting to the ending point. So there's, you find it, use your calculator, function int. You could do it by hand if you wanted to, but when they tell you use a calculator, use it, saves time. A lot of you wrote your integrand, so you found the integral and wrote it. Not your integrand, but you integrated and found the value. When it says write an integral, you're just writing what is there. Don't integrate it when you're asked to do that. Often directions say write an integral for blah blah blah, and you don't even have to evaluate it, so it's partly a reading question. Continuing, find the average value of the function. The average value of a function is a formula, 1 over b minus a, and the integral from a to b of f of x. So this is really a matter of plugging this in here and putting a definite integral up over your interval, and then use your calculator to evaluate. So the integral is 84 divided by 6 because you multiply by 1/6. That's the width of your interval. You get 14. Write but do not evaluate. Again, directions that you will see. Position takes into account positive and negative direction. So position, and we're going from 0 to 8. All you have to do to write the integral is that. Now when it says find the total distance, now we're talking the absolute value. Again, don't integrate. Write the integral. There's your integral, absolute value. And then to evaluate it, that's when you break it into parts. So the absolute value function equals 0 at 3. So you have to break it up into those two parts. And the left integral is 18, and the right integral is 50. (16) and 17 are the second fundamental theorem of calculus, which says the derivative of, you can't see it on this paper, but the derivative of the integral, we're finding the derivative. All you do is plug in x for t. There was an x there originally, we changed it. You could plug in x for x, it doesn't matter. So the first one's easy, 2x minus 3. You always multiply by the derivative of that upper integrand. And the derivative of the function from the a to the x, f of t dt equals f of x. So that's where that part comes from, that song. So on the second one, when you're plugging in x squared, you're plugging in x squared for both of these t values. So x squared to the third minus 3x squared squared, and then you got to multiply by the derivative of x squared, which is 2x. x to the 6th minus 3x squared. X squared to the third is x to the 6th, not x to the 5th. And you multiply by 2x. You get 2x to the 7th minus 6x to the third. These four are using the properties of integrals and give information when you don't know what f of x is, so it's a matter of plugging it in. When you know the distance from 1 to 2 is 3, and the distance from, or the area from 1 to 2 is 3, and the area from 2 to 5 is -8, that means 1 to 5 has to be those added together. The second one, we're multiplying everything by 2. We're adding those two together and multiplying it by 2. The third one, there is no quotient rule, so you can't evaluate that function with what is given. You need more information. It only works for sums and differences and constant multiples like this. Does not work for product, does not work for quotient. And the last one is understanding that when you flip the integral bounds, you get the opposite value. So it was -8 from 2 to 5, so it's +8 from 5 to 2. Next one is a Riemann sum problem, and remember there's 4 rectangles and the interval goes from 1 to 5. That's a width of 4, each of them is 1. And so you can see the little L's. We're using 1, 2, 3, and 4. We're not using the one at 5 because we don't have 5 rectangles, we have 4. And if you want, it helps, I think it helps to plot it so you can get an idea of your situation. It's coming off the screen a little bit. So if that would have been a right integral, we would have used 2, 3, 4, and 5, but it's a left. Same with the other one. This has 3 subintervals, and we're going from 0.5 to 6.5. That means each rectangle is a width of 2. So we're using the right 3, which would be 6.5, 4.5, and 2.5. You can see the R's on here. There's extra information in this table. Again, make a picture if you need to see a visual of it. We're starting at 0.5 and our widths are 2. So you have 3 rectangles, you're using these 3 x value as your points, and the y value comes from the table. On the back you were supposed to box, underline, and any keywords, and then there's extra credit to do the rest of the problem. So we want to box in command terms because it tells us if we have more than one question in our question. And some of you actually answered the questions, which is good. So what's happening in this situation is gravel's coming in and it's being processed at a certain rate. And so the goal is to try to figure out if it's processing at a rate that is increasing, decreasing, whatever. So the first one was simply finding the derivative, and it's a calculator question. It said technology is welcome, so when it says that, use your technology. So the first one is literally just taking the g prime of 5, showing what you did. And it's, since g is a rate, that's why reading helps. G was not the amount, g is the rate. So the derivative of that is the change in the rate, or it's like acceleration. So it was decreasing 24.5875 tons per hour. Units are important because it says use the correct units. Just to talk about the rest of this problem, for those of you that tried it, Part B says, find the total amount of unprocessed gravel that rises to the plant during the hours of operation. Total, integrals are totaling functions, so we're taking the integral of the function from 0 to 8. That's again a calculator question. That's how much arrives in that time. And question C says, is it increasing or decreasing the amounts? Remember, it's processing 110 tons per hour. That was in the given. And so we're at time equals 5, we find the rate. It's processing. We just plug in G of 5 in the calculator and you get 98. So that means there's more being processed than it's arriving, so the amount at the plant is decreasing at that point. Question D, probably the hardest question, is to find the maximum. And maximums on a closed interval occur at the endpoints or at where the derivative is 0. Remember, G is our derivative. So if you solve G, graph it and see where it crosses the x-axis, you get 4.923. And so you need to find the amount at any given point. So the amount at 0 is 500 because that was given. The amount at 8, you can't see it down here on the picture, but the amount at 8 we just found. And sorry, we found the amount at 8, but we didn't subtract the processing. So when you subtract the processing, the amount is less at 8. One way to think about this is that the amount at any given time is the 500 plus the 0 to t of g of s, but you have to subtract 100. So 500 plus integral of g minus 100. That's what this is. If you want to find that the amount, the rate, the derivative of that when that's 0, integral of a constant from the a to the x f of t dt equals f of x. The integral, the derivative of that integral is g minus 100. So that's where this 4.923 comes from. And then you just find those integrals. We always have to take into account the processing. So if you added 500 to the amount you just got and then you took away 800, that's where those numbers come from. You end up with like 525 for the last one. So when you check all three, the maximum amount at the gravel at any given point is 635. And then it works its way back down. So at the end of 8 hours, it's back down to 525. We'll practice a lot of those in the third trimester, but several of you got several points just by what you know right now. Again, this was all extra credit. The boxing and underlining was the part I want you to get used to, having a strategy for how you read these questions so you don't miss different things.